Okay, this is term 3, week 2, physics CA. Before starting, I want to shout out Ali Shaltuni. Uh, yeah, shout out to Shaltuni, Ali. Mohim, let me start. It's very easy. I think this recording shouldn't be more than 10-15 minutes. What is true about instantaneous velocity? Okay, instantaneous velocity, obviously it's a vector because you know velocity is a vector. It's not a scalar quantity, it's a vector quantity because it has a magnitude and it has a direction. But the magnitude of instantaneous velocity is equal to the instantaneous speed. If you get v instantaneous is equal to مثلا -6, then the instantaneous speed, okay, is gonna be 6. It's always uh, the positive version. So you know when we say magnitude, that means just take the positive. So I mean, well, you don't really need to know that, but no, I'm just trying to help you understand. The magnitude of instantaneous velocity is equal to the instantaneous speed. Instantaneous velocity is an arrow. It's represented as an arrow. Obviously, since it's a vector, it always has an arrow. Okay. Uh, is instantaneous speed the instantaneous velocity in a specified direction? If they said instantaneous velocity is the instantaneous speed but with a direction, then it would be correct. But here they're saying instantaneous speed in a specified direction. We know speed is scalar, so it doesn't have a direction, so this is wrong. You know, speed isn't, it's not a vector, so it doesn't have a direction. An object has zero instantaneous velocity if it's moving. Akid, no. If it's moving, then it's not zero. Question 2, the motion in which the velocity increases by equal amounts, obviously it's uniformly accelerated. Uniform because it's equal amounts, and since it's increasing, it's accelerating. Okay, so uniformly accelerated. Question 3, okay, they give you a graph, they want the average acceleration. You know, average acceleration equals velocity final minus velocity initial over time final minus time initial. So in this case, from 0 seconds to 4 seconds. At 0 seconds, it's 0, 0, and then at 4 seconds it's 4 comma -2 over here. Okay, so just do final minus initial, so -2 as the time and this is the velocity. Okay, -2 minus 0 over 4 minus 0, -2 over 4 equals -0.5. Okay. Question 4. Okay, same thing, but this time velocity or speed. They give you 2 points, 10 seconds 5 meters, 4 seconds 0 meters. What's the speed? Or you could say velocity. Velocity equals x final minus x initial over time final minus time initial. Okay, these term 1 formulas. Final x is, you could take any. You could take 0, you could take 5, whatever. Let's take 0 just to show you, you'll get the same answer. 0 minus 5 over 4 minus 10. It's going to be minus 5 over minus 6, which is the same as 5 over 6, which is 0.8333, kind of going on. So it's just 0.83. Question 5. Describe the motion of the skydiver in chronological order. Obviously, the first thing he does is jumping from the airplane without opening his parachute. And obviously, he doesn't open his parachute as soon as he jumps out of the plane. He waits a bit and until he speeds up and reaches his terminal velocity. Okay, after he reaches that terminal velocity, that's when he opens his parachute, right? Once he opens his parachute, he's going to keep on slowing down until again he reaches terminal velocity. The terminal velocity, if you forgot, it's the velocity that's constant. So at some point, you increase your speed to a point where خلاص, you can't increase anymore. That's your terminal velocity, it's the maximum. Or in other cases, in this case with the parachute, it's where you keep on decreasing your speed until خلاص, you can't decrease anymore. It stays at a constant velocity, being the terminal velocity. Question 6. A car moves 30 kilometers north, so plus 30, and then 60 kilometers south, so minus 60. It takes the car 2 hours to complete this journey. What's the magnitude of the velocity of the car? Okay, velocity equals x final minus x initial over time final minus time initial. Okay, final, hold up, moves. I don't know, would I do it like this though? 30. Hmm. You know, I wouldn't do it like this. And I'd do it, I'd do it differently. I won't use this formula. If you want to use this formula, you could do, okay, I'll use the formula and show you. But I'll show you another way. Obviously, your initial will be 0, 0, right? We're starting at 0. Okay, so you're moving 30 north, so you go up 30, then you go 60 south. This is 60, and you end up at minus 30, right? So your final x is going to be minus 30. If you want to use the formula, you have to use this way. You have to use your final as minus 30 and your initial as 0, because you're starting at 0. Okay, so you could use your final as minus 30 minus 0 over time final, which is obviously 2 hours minus 0 hours. You get minus 30 over 2, which is minus 15 kilometers per hour. The way I do it is, and I just take the displacement. The displacement, and I did is just 30 minus 60 equals minus 30. Then I divide it by the time, which is minus 15. Whatever you want to do, you still get km per h, and I don't mind. You get the same answer. They're saying magnitude, so you just make it positive. Minus 15 becomes positive 15. But what's going to be the direction? Since it was negative, obviously it's going to be going in the negative sense, and the negative sense is always south, because it's going down. Up is north, which is positive. Right is north, south, east, which is also positive. Left is negative, which is west, and down is south, which is also negative. Yeah. Okay, question 7. Okay, this is the UARM formula. The cyclist passes the start line with a speed of 2.8. So he starts with 2.8, so U equals 2.8. Okay, U means initial velocity, so his starting velocity. He's moving in the positive direction. He's accelerating at a rate of 0.2. Okay, what's going to be the displacement? So they want x. This is acceleration. They gave you a, and they gave you time 20 seconds. Okay, which formula has x, a, u, and t? It was x equals half a t squared plus ut plus x node. X node means initial x or whatever. Okay, I'm not gonna write down the formulas because يعني, I don't think you need all of them. بس okay, خلاص UARM, you have V equals AT plus U, X equals half AT squared plus UT plus X node. V squared, I'm going to put dash. V squared minus U squared equals 2AX. I think that those are what I can remember. There is one more, but I don't think we needed that one. So خلاص, just use these three. These are the ones that if they ask, they're gonna bring from here. Okay, x equals half at squared plus ut plus x. Okay, x is gonna be half acceleration 0.2 times t squared, so 20 squared, plus ut, which is 2.8, because u, we said is 2.8, started at 2.8. U is the initial velocity, times the time, which is 0.2, plus 0, because x node is 0. The initial, where are we starting? The initial displacement. Since we're starting at the start line, that means x equals 0 at the start. Okay, so this, if you put it on a calculator, you get 96. Okay, question 8. The horizontal component of force F. If you want the horizontal, remember you do F cosine alpha. Okay, but if you want the vertical, you do F sine alpha. Okay, so in this case, it's going to be 10 cosine 50 for the horizontal and 10 sine 50 for the vertical. And you're going to get 6.4 and 7.7. Okay, question 9. Okay, two forces, F1, F2, 30 degrees, 45 degrees. Okay, the horizontal component of the net force and the vertical and then the magnitude. Okay, so they want the total Fx and they want the total Fy. Okay, the Fx is going to be equal to the F1x plus the F2x, right? The Fy is going to be F1y minus F2y. Why minus? Okay, it's going to be minus because F2 is going down. Okay, so the y of F2 is going to be down, but it's still going to the right. That's why I kept the x positive. Okay, so let's find each one now. Okay, F1x is going to be 10 cosine 30. F2x is going to be 10 cosine 45. F1y is going to be 10 sine 45. Hold up. No, F1. F1. Yeah, 10 sine 30, sorry. 10 sine 30. And F2y is going to be 10 sine 45. Yeah, okay, yeah, that looks good. That looks correct. Okay, so fx is gonna be 10 cosine 30 plus 10 cosine 45, and the total fy is gonna be 10 sine 30 minus 10 sine 45. You just put this in your calculator. For fx, you're gonna get something close to 15.7. For fy, you're gonna get something close to minus 2.07. You know, I'll do it actually. How do I replay? Replay, replay. Yo, I can't go back. طبعا خلاص. Okay, I'll just write it out. 10 cosine 30 plus 10 cosine 40. For fx, you should get 15.73132.185. So just round it to 15.7. And then for fy, you should get minus 2.071067. So you just round it to minus 2.07. What's going to be the magnitude of the net force? For the net force, it's going to be radical fx squared plus fy squared, which in this case is going to be radical 15.7 squared plus minus 2.07 squared. If you want to write down the negative inside the inside the radical, make sure to put it inside the bracket, because if you don't, you're gonna get a wrong answer. It's gonna be negative answer. Okay, just make sure you put it inside the bracket if you're writing the negative. Some people, they don't write the negative when working with this formula, because aslan the negative is gonna get cancelled out because you're squaring. If you don't want to write the negative and just write it as 2.07 squared, again, that's correct. Yani. I think, you know, I've said this before. So you should get on your calculator 15.8358783, which is rounded to 15.8. Question 10. A 1200 kg car initially traveling at 25 meters per second stops in 5 seconds. Okay, what's the magnitude of the force? Okay, since we're working with mass and velocity and time or whatever, you're going to use F equals ma. Okay, we have the mass 1200, so F equals 1200, but we need A, right? But they did give us the velocity and they gave us the seconds, and they also gave us the final velocity. They're saying it stops, so the final velocity is 0, and it was traveling at 25, but the initial velocity is 25. How would I find acceleration? Remember, acceleration is v final minus v initial over the time. Okay, the final velocity was 0, the initial velocity was 25, right? Over the time, it was 5 seconds, صح? So it'll be minus 25 over 5, which is minus 5 as your acceleration. Okay, so it's going to be F equals 1200 times minus 5, which is minus 6000 newtons. But they want the magnitude, so you just keep it as 6000, keep it positive. What would the net force be if it's moving uniformly? If it's moving uniformly and it's balanced, and obviously 0. Okay, question 11. What's the spring constant? Remember that K equals F over delta L. Okay, K equals F over delta L. So the constant K, I just take the force divided by delta L. In this case, you can take any point you want. Let's take this one here. You have the force is 2, and delta L, the extension, is 0.04. So once you divide 2 by 0.04, you do get 50. So K equals 50. Question 12. Okay, gravitational force between two masses that are d meters apart is F newtons. If you remember, okay, they're saying the distance is 2d, so they double the distance. What will the masses be? So what will the force be? If you remember the force, the formula was G m1 m2 over r squared. So if you're doubling the distance and you're multiplying by 2 here, right? You're multiplying the distance by 2. Okay, and since we're squaring it, okay, G m1, wait. Okay, it's gonna be equal to F equals G m1 m2 over now 2 squared. Okay, this is how I like to do it. Okay, since now we did 2D, it's 2 squared, and that's how I do it. So that would be G m1 m2 over 4. So if you're dividing by 4, it will just be 0.25, because it's the same as saying G m1 m2 times 1 over 4. It's the same as that, and 1 over 4 is 0.25. In simple terms, square this number. If you have distance, square the number, so 2 squared, 4, and then just put 1 over that number, whatever you get here, and you get 0.25, okay? That's if it comes like that. I don't know, whatever. Question 13. A 5 kg box is placed. What's the equation for the weight? You know W equals mg, and I don't think anybody doesn't know this. Okay, if g is 9.8 was the weight, just do 9.8 times the mass. Sorry, 9.8 times 5. The mass is 5. So 5 times 9.8, you get 49 newtons. That's it. Thank you so much for watching. Good luck.